Hi everyone, and welcome to my talk, Simple Gestures Can Go a Long Way. Before I dive into it, here's a little bit about myself. My name is Gerard. I'm currently a developer advocate at Stripe, where I spend my time either collaborating with our product teams before shipping features to make sure that we provide the best quality possible, and also after we've shipped, providing different ways for developers to use our products through educational material, SDKs, and more. Apart from that, I'm also a Google developer expert in web technologies. I'm the author of a book about machine learning in JavaScript. And overall, I'm a self-proclaimed creative technologist. I absolutely love exploring how far I can push the boundaries of what can be done on the web, and hopefully I'll show you a little bit of that in this talk. All right, let's get to it. So let's start at the very beginning with human-computer interaction. So in a very broad definition, HCI is a subfield of technology focused on the interaction between humans and computers. So in terms of inputs and outputs. In your day-to-day, it includes using a mouse, your keyboard, a touchscreen, voice assistants, other different ways to interact with technology. And it's something that as front-end developers, we might not hack on very often. Most of the time, we rely on standards already available, and we just use them through web APIs like, on-click events, on mouse down, and things like that. But that's not because most of us don't define these standards that we can't have fun making our own interactions. And an exciting example of that is with motion detection. So if I ask you right now to think about motion detection in your day-to-day life, you might think of something like this. A standard motion detector that is used to turn lights on or off in an office or outside your house, or even as a security alarm system. But that's pretty much it. What it detects is basically, is there movement or not? It doesn't particularly detect specific movements. For example, it doesn't know if you're walking or running or jumping. It just knows that there's movement. A fun thing to know, though, is that if you ever want to build your own standard motion detection IoT device as a front-end developer, you can. Using Arduino and a motion sensor like a small radar or a PIR sensor, you can get data and customize your device using JavaScript. But these two sensors, so the small radar and the PIR sensor, they're just as standard as the one that you can buy in store, meaning that they can detect some kind of motion, but that's it. And movement is actually much more complex than only is it happening or not. Motion contains a lot of more contextual information. For example, if I do a thumbs up, it means something different than if I'm waving my hand, or like if I raise my hand to speak, it means something different than if I raise my hand to signal to the bus or a cab that I needed to stop. So could we take advantage of the complexity of movements to build smarter, more customizable system as a front-end developer? Well, the answer is yes, and that's why I'm giving this talk today. So it is definitely possible. And even better, it's possible in less than 50 lines of code. So the first step is to use a microcontroller with a built-in accelerometer and gyroscope sensor. So the one that I'm using here is called the Arduino 33 Nano BLE board. It's super small and it costs a bit less than $20. I have it here, so I have it on like a foam thingy for later for my demo, but it's actually super, super small. So the reason why you'd need a board with an accelerometer and a gyroscope is because you get 3 points of data for how your body rotates, so with the gyroscope, and 3 points of data for how fast your body moves from the accelerometer. So you get X, Y, and Z coordinates for both attributes, so rotation and acceleration, multiple times per second, which gives you quite a lot of data to define different movements. Okay, so that's for the hardware part of this project. But how do you actually get this data and do something with it? So for the software part, we need TensorFlow.js and Arduino. If you've never tinkered with Arduino, don't worry, you mostly need to upload a pre-written sketch to the board. You don't have to write any C code. Of course, if you want, you can also do that. But for this talk, if you don't want to, the sketch is available, you only need to upload it. And with TensorFlow.js, You can decide to do everything on your own, so meaning you can decide to handle the connection to the Arduino and then collect the data and then process it and then create a machine learning model and then train it and then export it all in JavaScript. So you can do this all on your own, or you can also use this great project called Tiny Motion Trainer. So it allows you to do all of the things that I mentioned just before, so all of the steps, but in just a few minutes. So you train multiple gestures in the browser, and you generate a machine learning model and export it via the UI. So I'm going to try to show you quickly how it works. Okay, so here, this is the homepage of Tiny Motion Trainer. So I'm going to start a new project. And here it's asking me to connect to my board. So I'm going to click connect. I should be getting, yes, a list of devices connected to Bluetooth that I can connect to. So I'm going to pair. And once the pairing is done, here we can see on the capturing threshold part that it's moving. So if I'm moving the sensor, I can see that I'm connected. You can specify what kind of settings that you want, but just to show you how the platform works, I'm going to leave the default one. And I'm going to move on to capturing data. So here is where you're going to define the gestures that you want to train. So for example, my first gesture, I'm going to write wave. So here I have a wave label, and I'm going to hold my board here, but I'm going to, hold it like that. And I'm going to start recording, and I'm going to do wave. Wavy. All right, so I'm going to stop after, I have 9 samples. That's fine. That's good enough. And then another one that I'm going to train for an example is punching in space. So I create a new label, I select it, and then I'm going to make sure I'm not punching. Okay, I'm going to click start, and I'm going to punch, and we punch. I have 9 samples as well, so I have enough. Okay, so I'm going to stop recording there. And now that I created at least 2 different types of gestures, I can click on the train model. It's going to start the process. It shouldn't take too long, so the length of it depends on how many samples you record per gesture, but also how many gestures that you want to train. And here you have some graphs in the UI if you are interested later in seeing about the accuracy and the loss, but we should be all good. Okay, so now that it's finished, I have this, I can test my model before I export it to make sure that I recorded the right gestures. So if I wave, yay, I have like the wave, and if I punch, I have, it's pretty good. So we're at a point where we can export it if you want. I'm not going to do it here because for the demo that I want to show later, I have another model. So I'm going to go back to my slide. So I'm just disconnecting a little bit. Okay, so this was Tiny Motion Trainer, but now that we've trained a model with our different gestures, how do we actually use it to add gesture control to a web app? And the trick is, in the script provided by the team at Google Creative Labs who built Tiny Motion Trainer. So it's a script that you have to add to your app that makes available a method on the window object called TinyML Experiment BLE interface. And you might be wondering what's in this mysterious script. I don't have time to go into too much details in this talk, but it handles the connection and communication with the device using the Web Bluetooth API. So it uses the different services and characteristics UUIDs to connect and transfer data between the device and the browser. You don't need to modify that code at all. You only need to import it. It handles the logic, so you don't have to, and you can focus on building your app instead. So what you can tinker with, though, is the methods that it exposes. So first, it allows you to create a button on your page to connect to your Arduino device. And then you can pass the model's parameter. So first, the path to the file. So when you export the model from Tiny Motion Trainer, you can then add it as a file or as a folder in your app, and you can indicate the path there. One awesome thing about TensorFlow Lite files is that, well, they're pretty light. My custom model is 2 different gestures, and it's only about 16 kilobytes. And comparing to other models that I've used in the past, especially around object detection, they're usually multiple megabytes, which had a big impact on performance. But 16 kilobytes, like, you know, it's pretty good. I mean, it's not like super light, it could be lighter, but for a machine learning model, I mean, I'm impressed. I mean, 16 kilobytes, it's like more than 5 times smaller than jQuery. I mean, last time I checked. So then we have to indicate the number of classes or gestures that we trained. Here I have 2 because, well, I trained 2 gestures, but you can train more. I don't know how many you can go for, but at least, you know, my 2 ones that work fine. Then the threshold is a value between 0 and 1. And it represents the threshold at which the model will start to classify a certain gesture. So it doesn't try to detect micro gestures, like if I'm moving my arm like super slightly, I don't want it to detect that. So the closer to 0, the more sensitive it's going to be. And the closer to 1, you'll have to execute a pretty intense gesture for it to classify it. Then we have the number of samples that represents, well, the number of samples that you recorded in the UI for each gesture. And then the capture delay is the delay between samples of data used to recognize gestures. So the closer to 0, the faster it's going to look at new live data to predict a gesture, and the closer to 1, the slower. And what I mean by that is that the amount of live data is going to need to collect before kind of like triggering a classification is going to be more or less large. And then you have a few different events available, such as on connect or on transfer progress. That one is triggered when the model is being uploaded to the board. And you also have on transfer completed, on disconnect, but maybe most important is on inference. So this function executes when receiving data from the device and tries to predict your current gesture based on the data recorded in the training step. So we can see here that on inference called another function called on inference sketch. I could have definitely changed the name of that function. I think I just used a default one from a boilerplate. But it takes a parameter called data.index, which represents the index of the gesture trained. So it could be 0, 1, or 2. If I have 2 gestures trained, then my index will be 0 or 1. And finally, based on the index, we can trigger any kind of front-end code that we want, sounds or animations or calling like an API or, you know, anything that you want. And that's pretty much it. Like, I almost feel bad that the code to do this is so small, but at the same time, it's amazing. So to recap, you have to start by uploading a sketch to the Arduino. I didn't show you this part because it's not the most relevant to this talk. You know, you won't have to change the C file, so it will probably be clicking a few buttons. Then you train your model in a tiny motion trainer for a few minutes. And then finally you add the JavaScript script written by the Google Creative Labs team, and you write your own custom JavaScript in your app. All right, so to show you an example of what you could build with it, I made a little demo and I kind of customized it for this conference, and hopefully it will work, but let's give it a try. So if I go back to my presentation and yes, okay. So here, I kind of like hacked something together. I'm on the prod site of Devs for Ukraine, but I made some custom changes using local overrides on Chrome. So it is the prod site, and I've added my own kind of like little code to it. So I'm just going to refresh just to make sure that I can connect my device properly. All right, so here you can see a little connect here. That's just to be able to connect my board. So I'm querying devices. I have my Arduino here as well. And then I'm pairing. And one thing that I didn't mention is that, look at this, like it's actually live, like transferring a machine learning model to the board via Bluetooth. I mean, like, it's amazing. I mean, it's really, maybe it's like not a big deal for you, but I think that that's actually super fascinating. I mean, like, that's amazing. I mean, I'm a fan. Okay, so now that the model is uploaded to the board, I'm doing my own like this is, I mean, wait, what, you're gonna see what I mean. Like, this is very DIY. This is, yeah. So basically, what I did is I created a gesture, and as it's about donating money, that should be doing a thing where if I do, I hope that you heard the sound because my microphone is kind of like filtering sounds, but there's a little like ka-ching. So if I do like, yeah. Woo! Okay, so I'm going to stop here. And so you could see that I trained the model to recognize that gesture. And then it's updating the inputs on the site, and then I can give money. And actually, I realized that there was a little problem because it's not showing me the pay button. So I'm just gonna, it should be showing this, and then you have like pay with Stripe. And yeah, so that was kind of like the demo. I'm gonna stop here because I was, I'm gonna stop here before it does something weird. So if I go back to my slides, so that was like my little demo just for this. So maybe if you're not interested in using this to throw money around, there's actually a lot more that you can do. For example, a few years ago, I used Web Bluetooth and JavaScript to connect devices called free drums to the browser to make some music and trigger animations. So this was not using Tiny Motion Trainer, but it was something else. But you could definitely do something like this with what I've shown you today. And actually, some people have done exactly that. It's an experiment called Air Snare. So if you already have an Arduino 33BLE laying around as you do, you can check out this experiment and more on the Chrome Experiments website. And another example is my Air Street Fighter project that uses motion data from 3 different gestures to trigger the movements of a character on the screen. So the first version of this project was done without Tiny Motion Trainer as well. I think that project wasn't available at the time. So I wrote the entire logic, meaning connecting the device, collecting the data, and then processing it, making the machine learning model, blah, blah, blah. And then I wrote a second version of it that used a model exported from Tiny Motion Trainer, which allowed me to rebuild this project much faster and in a lot less code. So that was really cool. And that's an example of things that you can do if you want as well. But on this, thank you so much for listening. Hopefully you learned something in this talk. And if not, I hope that at least you had a bit of fun. That's also very important. If you have any question, feel free to let me know. But if nothing comes to mind now, no problem. You can reach me later. I'm at DevDevCharlie on Twitter. But thank you very much.